Hi there, everybody. We're just spending a little bit more time here on some linear problems, and by that I mean perimeter and I mean circumference. And I know that you've had a lot of work with perimeter and circumference so far, and a lot of problems to solve. But believe me, I want to ensure that you know what you're doing and you can calculate all of these things. And that's why I've given you the answer key all the time. And you need to leave this course knowing how to do some basic calculations. You'll notice that this lesson, you'll know right away, this is very short, and I just thought I'd spend a few minutes talking about some a little more complicated problems that you might run across that still deal with perimeter and circumference. So for some of you, this might be a complete waste of time, might be very easy. For others, it might, this could be a little bit more difficult. So what I'm going to do is just show you two examples of what you might come across. Example 1, a person has a front door with a semicircular window and has a base length of 60 centimeters. Calculate the perimeter of the window. So essentially what we're looking at this window right here. So it looks like this, it's a semicircle. And we know that the base is 60 centimeters. But the person wants to know the perimeter. So we know the bottom. So what we're lacking essentially is this part right up here. Well, in that case, that's a semicircle, which essentially means half a circle. So what I'm going to do is I'm going to use a circumference formula. Now you see this 60 centimeters down here. That goes from one side all the way to the other. That's going to be diameter. So I'm going to use the pi times diameter formula. I'm going to fill that in with 60 centimeters. And I'll just put this here on my calculator quickly. So that gives me a circumference of 188.495 on and on centimeters. But the problem though is, everybody, that the circumference formula deals with an entire circle. So if you use this formula, that's a circumference of an entire circle with a diameter of 60. But you can see I only need this part, everybody, which is a semicircle or half of a circle. So if I want that, all you have to do is divide by 2. And that will give you the semicircular distance, or half the circumference, which in this case is 94.25-ish centimeters. So we know from here all the way to here is 94.25 centimeters. If you want to know the perimeter of the entire circle, you'd have to take that 94.25 plus the base. So there'd be one last step, just adding that. The true perimeter of this circle is going to be 154.25 centimeters. Now again, nothing here is new or groundbreaking. I just wanted to show you some examples of where these calculations could go. We'll move on to one more. This is a very common one coming up. It has to do with a running track that you would typically see. Sometimes they talk about hockey arenas. It doesn't really matter. Essentially, you have a shape with kind of two rounded sides and then two flat sides. Your best strategy here is to always fill in what you know, or to draw a diagram, make a diagram, and fill in the information. As you can see in this question, we do have a base diagram given to us. The following diagram shows a layout of a running track. The ends are semicircles with a diameter of 50. The perimeter of the track is 400 meters. Determine the length of each straight side. So what we want to know here, everybody, the question is, how far is a straight side? What we do know about a circle, and if you are familiar with a track is supposed to be 400 meters. So a perfect track is 400 meters around. That's what we know. So if you were to start right here and to run around perfectly and come back, you will have run 400 meters. So that's going to be, we're going to have to use that at the very end here. I tell you what we can do here though is, how do we get to this straight side? I want to figure that out. So here is the deal. Do you see these two semicircles? See this one here and this one here? Well, if you put two semicircles together, so if you took this semicircle and added it to this semicircle, well, wouldn't that give you one perfect circle? It would. So what I'm going to do is I'm going to use circumference equals pi times diameter. Pi times, what's the diameter of this thing? It's 50 meters. So that gives you a circumference of, that's going to be, oh wow, did I make a mistake there? Pi times diameter 157.07 meters. So here's the point, everyone. What have I done so far? I figured out the circumference. Well, who cares? Well, I know that if you take, so if you can follow my pen here, from here to here and here to here, what shape is that? If you put them together, that is one circle. And I know that if you take this distance and this distance, that is 157.07. So now, let's look at what we have. The entire track is 400 meters. If we take off the contribution of these two semicircles, that will tell us kind of what we're left over with here. So I'm going to go 400 take away 157.07. That is 242.93 meters. That's what we have left. So what do we still have to account for? We still have this straight edge and we have this straight edge. Well, we've accounted for this. Let's get rid of that. So we have to take this straight part, this straight part. I have 242.93 meters and I have two straight sections. To me, that simply means divide by 2. In this case, one straight edge is 124.465 centimeters. I suppose what I'm trying to show you here is how you can have straight line measures and circumference coming together in one equation or one problem. You may want to watch this example again. So what did I do? I looked at the two semicircles on each side. If I put those two semicircles together, that's a whole circle. And we know that the distance around a circle is a circumference, so I could figure that out. That gave me 157.07 meters. Then what I did is I thought, well, I know the whole track is 400. So I went 400, take away the circular part, which left me with 242.93. That was how much each straight side was. But the question wants to know, what's the length of each straight side? So what you had to do was take 242.93 and divide it by 2. That means each straight side is 121. So basically this bottom is 121.465 meters, not centimeters. And this one up here also is 121.465. You may want to try that one again. I will give you some more practice with that. So essentially the practice you're going to do now is just kind of some more of these a little bit tougher problems that deal with linear and circumference measurements.